let's try to explore the object-oriented programming features of Scala, right? So far we looked at the the data types, and we looked at the control structures, and we looked at the collections, right? So now let's look at the object-oriented programming features. So like you all are familiar with, an object-oriented programming language, provides a structure called as a class. So for those of you who are not so familiar with the object-oriented, programming paradigm, so the object-oriented, programming approach basically tries to, to basically represent the complexities of the data of a particular domain in the form of objects, right? So objects, represents, the data, or model the data, in the real world, right? So basically, you can model the data after the real world entities, which are called as objects, right? So in object-oriented programming languages, the objects are supported by a structure called as classes, right? So so you basically define a class, and this class can basically have member variables and associated functions that is supported by this class, right? So this way you can model the complexities of the the business domain which you're trying to capture in the in the data, right? So here you group together the related data attributes and associated functions along with them, right? So in a class you can have member variables which are part of the class, and member functions which are also called as methods which are part of this class, right? So classes in Scala is very much similar like the classes that you have in Java or C++, right? So for example, we can have something like a class here, right? So I'll define some class point, something like this, right? Now I'll provide two parameters for this. So I'll say x coordinate, which is an integer, and y coordinate, which is another integer, okay? And in my class description, I would say it has two variables, variable x, which is of type integer, okay, and I'm assigning this with the first parameter, okay, and variable y, which is also an integer, and I'm assigning the second parameter to it, okay, and I'm also defining a function within this, right? So called as move, which takes in two parameters. So I'll say an x coordinate, which is of type integer, okay, and a y coordinate, which is also of type integer, okay, and I'm going to define this function, okay. So within this, I'll just say x is equal to x plus dx, and y is equal to y plus dy, okay, and I close this function, right? And I'm going to have one more function within this. I will say override, okay, so override the function and create a new function which is toString, okay. So this toString function, I'll say returns a string, and this is equal to, I will say I'll just do some formatting here, So this is going to return something like this, plus x, okay, and plus, comma, plus y, plus something like this, okay, and I'll close the brackets, okay. So what am I doing here? Just look at it, right? So here I'm defining a class, okay, which has two variables, x and y, okay, which are called as member variables of this class, okay, and I'm also defining a function called as move, which is a member function or a method of this class point, okay, and I'm also having one more function within this class point, which is overriding the default toString method and providing some implementation for this toString method, okay. In this case I'm just formatting the the way in which it has to convert the contents of this point class into a string, right? And then I'm closing the brackets, right? So here, this is how you create a a class, right? So a class has member variables and member functions, and here when you're declaring or defining a class itself, you are providing some parameters which are basically used during the construction of an object of this class type, right? So basically a class would have a constructor, okay. Constructor is a function which is invoked whenever an object of this particular class is being created, right? So this is how you define a class. Now, once you have a class, right, so you can, say create a new instance of a class using a keyword or a primitive called as new, right? So using the new keyword, you can create an instance of a class, right? So now we have defined a structure called as a class, okay. Now if I want to create a an object of this class, so I can say, for example, val point is equal to new point of, maybe I'll say 1 comma 2, okay. So you can see here now this PT is basically an object of this class called as point here. Okay. Now let me invoke a function. Okay, so we have a member function which is called as move. So we can access that function. Say, for example, I can say pt dot move, and I need to provide some coordinates there. So I will say maybe 10 comma 10. Okay, so it has done something. So move is a member function of this particular class, right? So for example, see, when you see a tuple, what is a tuple? A tuple is an ordered set of values of different types, right? Similarly, you can think of class as a even more complicated structure, which is an ordered set of data types and the functions associated with the data, right? So in this case, I'm grouping together some variables here. For example, x and y, which represents, to me, it represents the coordinates of a point, right? So this is a x coordinate and this is the y coordinate, how a point is represented. And within this, I'm also defining a function called as move, which does this following, right? So which has its implementation here, right? So now when I created a new object, this object has got access to all these functions, right? So I'm now invoking the move method of this function, by referencing it as a part of its object. See, the move method, if you observe, it does not return any value. Okay, there is an implicit return type which is called as a unit. Okay, and this is inferred for this function. Okay, so unit is something sort of which corresponds to the void in a Java language. Okay, so in Java you define void, right, explicitly, but here compiler implicitly returns a unit which you already saw earlier, right? So so the return value is inferred as far as this function move is concerned. Okay, now compared to this other method which is toString. So toString, on the other hand, it does not take any parameters, but it returns a string. Okay, so the result of this expression is basically a string, right? So it's basically a formatted string in which you have enclosed this within these curly braces, right? So the two values being enclosed in curly braces. So this comes as a return value of this function. So therefore, you are seeing that the structure, I'm saying it is returning a string. And by using this keyword override, so this overrides any previous or a predefined implementation of the toString method. Okay, so in case if you're trying to use any function name which is having some predefined implementation in Scala, you can use the override function so that you can override the predefined Scala function. Okay. Now we did a move, so let's invoke this toString method and try to see display what has happened to our member variables. Okay, so I will say println of pt, okay, which will internally call the toString method, right? So let's see this. Okay, so this pt, when I invoke this println, so this is internally calling the toString, and this toString is overridden, so it's going to invoke the implementation which I have. So that is basically formatting the println function. Okay, when it takes the parameter pt, and the println function converts that to string, and it displays the output here.